Welcome back to the channel. Today we're going to be continuing our Sega Genesis development series, and today we're going to be taking a look at how to detect and potentially use in code the region of your system. So this will kind of give you the option to filter on maybe a menu language or really do anything you want revolving around the region of the system, which is basically going to tell you whether it is Japanese, European, or US, American, as well as the video, which will either be PAL or NTSC. So what we're going to do is we're going to fire up Visual Studio Code. And we've already got Visual Studio Code set up with the SGDK using Genesis Code plugin. If you need help setting that up, check out my previous videos in this series. I go over that, but we're gonna do the command palette, and we're gonna do Genesis Code create project, and let's just navigate to our code folder here, and we're gonna create a new folder, and we're just gonna call this Genesis region. Select folder. This is going to create our project, and we're just going to open up the source file, and the first thing we're going to do, we're just going to make sure it runs. So open up the command palette, we're going to do Genesis Code compile and run project. This should open up the emulator, which it does, and has Hello Sega in it, so we're good there. So what I'm going to do is I'm going to show you how to detect the region. So the Sega Genesis has a memory address base that allows you to pull basically a byte from memory that contains the region of the system. So that's what we're going to do, and then once we pull that, we're going to be able to extract 2 bits out of that byte. One's going to give us the video, kind of that video signal PAL versus NTSC, and the other is going to give us a region, which is basically either going to say whether it is Japanese or foreign, and that foreign could be either US or European, but when we build this out, you'll see how we have the capability to kind of determine PAL or NTSC, so we can kind of tell whether it's a European or other non-US region that's running PAL, or whether it is a NTSC or an NTSC Japan. First thing we're going to do is we're going to grab the console version. So we're going to do U8, and then our variable name, we're just going to do console version equals, and we're going to have to cast that memory address space to a U8, so we're going to do asterisk parentheses U8 to cast it. Alright, and then the address space that we want is going to be 0x10001. And that'll get us the address space. The next thing we're going to do is we're going to load up a variable that will give us a placeholder to store the region just for output. Just so that we can kind of do an output here. So we're going to do, oops, wrong language. We'll just go ahead and name this thing version code. And just for testing purposes, we'll make it 12 characters long. We'll initialize it to an empty string. Then the next thing we're going to do is we're going to load this console version into this character array. So let's do sprint We're going to do version code, and then in here we're just going to format this string. So we're going to say console version, and then we'll do %X, and we want to pull it from the console version variable. So if we do this, and now if we draw this to the screen, so let's do draw text, and we're going to draw the version code, which is that buffer we just loaded. And let's put it, we'll just put it at 2.2. Alright, so now if we save this, open command palette, compile and run. Alright, so now what we see here is we have A0. So this is our hex representation of what is stored in that byte. Now if we go to country, and if I select Japan as an example, and do tab to do a reset, here we can see it's now 2.0. And then if I go to Japan PAL, we'll see it switches over to 60. And then US is going to be A0. And then Europe PAL is going to be E0. Now, something very important to know is when you're looking at these, this byte, the hex value is variable, meaning what you see in the emulator may not necessarily be what you see on a console. It's kind of up to the manufacturer to handle the address, but what they have to do is they have to do A through F, right? So it could be a A0, a B0, it varies. So what we want to do is we just want to extract the bits out of that byte to have a more standardized and really more accurate representation across all potential platforms. So in order to do that, we're going to write some code here to extract the bits. So we want bit 6 and bit 7 out of this byte. So bit 6 is going to be the video bit, and bit 7 is going to be our region bit. So let's start with bit 7. And we'll just do console region bit here. And what we're going to do is we're going to use a mask to extract this. So we're going to do console version. We're going to do an ampersand, and then in parentheses, we'll do 1, and then a double less than 7. So this will check to see if that bit 7 has a value of 1, which essentially means true in this instance. Okay, so this should give us that, and now we're going to do the same thing for the video signal. So we're going to do console video bit. We'll do console version. And this time we want to apply the mask to bit number 6, or bit position 6. And then 6 again. Alright, so now what we can do is we can apply an if-else block to see what system we have and kind of output that to the screen. So what we're going to do here is we're going to basically just do a bunch of if-else blocks. So we're going to say if the console region bit equals 1 and the console video bit equals 1, meaning both bits are set in that byte, then in this case we have a PAL system. So we're just going to do VDB draw text PAL 2, 3. Alright, and how do we know this is a PAL system? Well, you have to look at it from a standpoint of the system was made in Japan. So all the code is basically kind of driven off of the assumption that you're in Japan. So if the region is set, that region bit is set, it means it's an international system from a standpoint of Japan, not a standpoint of America. So we've got an international system, and if the video bit is set, it means it's PAL. So in our case, we know this is an international PAL system. Domestically in the US, we know all of our systems are NTSC. So we kind of know this is a European system. It could be Brazil, it could be other regions, but we know it's a PAL system. And then the next thing we're going to do here is we're just going to copy this. We're going to apply another check. And in this case, we're going to say if the console region is 1, meaning it's international, but this time the video bit is 0, meaning it's not set. This tells us it's an NTSC system. This is typically going to be your American-made systems. Now we can just copy both of these, make things a little bit easier here. And in this case, we're going to check where the region bit is 0, right? So we know this is going to be a Japanese system. And if this is set, we know that we have, so in Japan, they have both PAL and NTSC. So we know this is going to be a PAL J. And then if the console region bit is 0, and the video bit is 0, meaning neither of them are set, we've got an NTSC-J system. So now what this should do is we can actually get rid of the Hello Sega. We'll just comment that out for now. If we compile this and run it, we now see, okay, we're on E0 right now, so we've got European, and our console is PAL. And if I switch this to USA, hit tab to reboot the system, we've got NTSC now. And then if we do Japan, this should be the NTSC-J, which it is. And then if we do the Japan PAL, we now have PAL J. So that's just a quick, easy way where you can essentially load up two variables that will allow you to access kind of the region you have and also the video. Video could be used to speed up, slow down your game based on whether it's PAL or NTSC, or you could also use this to kind of default a language menu. If your system supporting both Japanese and English, you could use this to drive that language. Kind of a default. I always recommend creating a language menu that allows the user to select it, but you may want to do a default on that. There's an unlimited number of ways that you may want to use this data. Purpose of this video was just kind of show you how you could pull that data, how you would extract it and test it using an emulator. And in this case, we were using gens. We can also do the same thing with regen. So if I do Genesis code and let me just switch this real quick to regen. And I'll show you the reason I used gens here in a minute. Alright, so now if we compile and run, this should load up regens. Yep, first time. Alright, so this time it loaded up the regen emulator. And on this one, what we have is a little bit different. Let's see where that menu is. Country. If you notice here, regen on Japan, it doesn't have both codes, right? It doesn't have NTSC and PAL. So if we do a hard reset here, you can see that regen only does, for the Japan menu, it only does NTSC. It still has the version of 20, so the same as the other emulator. And if we do USA, we've got NTSC, it's still an A0. And then if we do Europe, let's see if it's an E0. And it is. So here you can see we're able to extract them from both emulators. If you did this on an actual Genesis system, you'd be able to extract it as well. But that's it for this video in the Sega Genesis development tutorial. Drop me a comment below, let me know your thoughts, and let me know what you would like to see in a future video in this series.